So hi everybody, so thanks for coming to this session. So my name is Kevin Donnelly, I'm Partner Solution Engineer here at VMware. Also a subject matter expert in Internet of Things and VMware solutions in this area. So very quickly, this is the session, DevOps Lessons at the Edge for Cloud Architects. Here's our little disclaimer, I have to show this at every session. Okay. So this is a code session. So I'll be sharing with you today some of the lessons that we learned from this project, lessons that we learned the hard way essentially. So has anyone heard of the NASA Mars Exploration Project or seen the movie The Martian? So you can probably remember the Martian movie for where he grows the potatoes in the movie, right? For me, the reference to me is where he finds the Mars rover, okay? And he also has a base camp set up on Mars, which essentially has a whole heap of monitors and compute. So essentially has a compute edge there, okay? Now, just to put edge computing in perspective for you guys, the communication delay for Mars is about 14 minutes, right? So this is where we really need edge computing to take over for us, because in 2012, the Curiosity Mars rover program, they tried to they landed the rover on Mars, and essentially they had a 14-minute delay where they didn't know what was going to happen. So in these 14 minutes, they had, so they called it 7 minutes of terror, where they literally didn't know what happened to the rover because it takes 7 minutes to land it, and they had the 14-minute delay. So, can you imagine spending all that time and effort and then not knowing whether it landed successfully or whether it didn't? So, there's a link, and I'll show you that at the end. It's called 7 Minutes of Terror. I highly recommend go and have a look at it on YouTube. So today, I'll be talking to you about how we built an autonomous model of a Mars rover, just to demonstrate VMware's solutions for Edge and for IoT. Okay. Now, just to quickly set the scene, who here programs on a daily basis? Anyone program? Yep. Good, cool. So before we started this project, we had little to no experience of programming or the kind of tools which you can use, in that kind of environment, right? So essentially, trying to program was like speaking Martian to our guys, right? It was interesting. So just going to quickly walk you through the agenda. So firstly, I'm going to talk to you about some of the constraints that we had in the project, things around timelines and working in distributed teams. So this can help you to take these learnings onto your own projects, all right? Next, I'm going to highlight some of the challenges that we had around component selection and coding etiquette. So you guys can understand when you leave here to better interface with unfamiliar tools and dev teams. And then finally, I'm going to discuss the lessons that we learned throughout this project, from build right through to production and operation, test and troubleshoot, so you can then help your business drive new features to the market quicker. And also because you're going to know about how to interface with these teams. We'll have a bit of Q&A at the end, if we have time, but if not, feel free to come up and have a chat. Okay, so here's our timeline. So as you can see up there, we had a bunch of silos where we had people working on different pieces of the project. We had a couple of hackathons. If you've ever done a hackathon, you get locked in a room for a day, just order pizza and coffees all day, and you just work hard on that kind of thing. So that was our timeline. Now, it looks like I had a lot of time, but when from July to October, we also had our day jobs to do, so there was, the time quickly bustled up. So here's a team. So we had 8 people working on this project across states and across countries. Just to give you an idea, there's a 2-hour delay from New Zealand, which is over there where my teammate Tessa was working, into Australia. So we had a couple of people up in Queensland there, Matt and Pete Lindley, working on our VeloCloud and some sensor operations and network configuration. Myself, Matt Chamley, and Dean Ravenscraft, we built the body. We had Matt worked on the camera, and then we had Dean doing some coding. Tessa on the right there in New Zealand, she worked out the logic for the drive code and actually we were cutting our teeth on Python to integrate all of that. Adam and Simon, they were working on integrating a couple of sensors. So we had quite a distributed team and distributed workload, okay? So in our hackathon, here's some of the outputs that we had and some of the decisions that we kind of wrestled with around this sort of things like battery power, weight, speed, distance, sensor logic, and all kinds of other things. Now, something that came up pretty quickly in this project is, does anyone actually know what this is in the left here, this red piece? No, it's not a Raspberry Pi, Nick. That's actually an H-bridge. But so something that came to light was that when you're designing an IoT solution, the hardware interface and the software interface is so important. They really need to be co-designed. Okay, so as I said, the red item is the H-bridge, which is the part that allows it communicates from the Raspberry Pi to the motors to basically then transfer voltage and current to drive the motors either forward or backwards. So because my teammate Tess was working on the drive logic in New Zealand, and these parts were actually in quite short supply, we needed something that she could work on in New Zealand, and we could still make our timeline because we couldn't get these parts quick enough, and obviously she didn't want to go and duplicate the parts, and we needed to test the code as well. So that's something that we came up with. So I'm just pressing space over here. So meanwhile, while the other guys were working on in our silos, like I just said earlier in the map, this is how the Mars rover came to life, the model of it. We had a box of parts from Bunnings or any kind of home warehouse place that you can buy. Then here's me turning my apartment and kitchen into a bit of a workshop. Okay. So because we're working in silos without consistent configuration, we actually had quite a bit of pain down the track. So developer insight here is you don't want to worry about the setup, you just want to write your code. You don't want to worry about what hardware you need to code to or program to. You want to kind of be able to just get straight into writing your code. So enter Tessa's, this is Tessa's rig of coding that she set up. So I'll just see if the video runs, give me a second. There we go. So she puts her hand in front of the sensor and it changes to red. So that's basically, she's coded that to say drive forward is green and then go backwards is red. So this really helped to get a test rig that we could then use, and we could actually test it on our model. So we were programming different countries. So, and just to Nick's point here, the Raspberry Pi, and you'd be surprised how many people ask me why I put a cake into the Mars rover. I'm not looking at someone in the front row. But this is a Raspberry Pi. So the pins on the top here, on the top left, if anyone's seen these before, these are called the GPIO. So you program against these pins based on the map on the right there. So there's a mixture of ground, 3 volts, 5 volts, and then the rest of these you can program using Python code. There's a Python library which you can then code against. Okay. Now here's a bit of an interesting story. This is a before. So as we said before, trying to learn the tools and understand what we were doing. We were using GitHub. If anyone used GitHub before here? Yep, cool. So we're using GitHub to move code around between New Zealand and Australia. So one night, it's brought some challenges. So one night, Tessa, she was working on the code, and she uploaded the code to GitHub, and because of the 2-hour time difference, and this late nights, she went to bed. I downloaded the code onto the rover, tested it, and it didn't work. And Tessa had gone to bed, so I went on the internet and found some random internet code, downloaded it, got it running, all good. Okay, I sent an email to the team, said, hey, it's all good, we got it running, no problem. Okay. No. And here's 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 a video of the rover in my apartment there. So we had some design challenges there where we had to try and tweak some things. So downloading this internet code and running it on the rover was all good, but we'd actually broken one of the rules of coding. So these rules here, these 9 rules come from Jez Humble. There's some links at the end where you can look this up. So we broke the rule, which is don't check in a broken build. So don't check the build and then go to bed, right? Don't go home on a broken build. Try and time box your fix before you revert back to a known good solution, and obviously take responsibility for all breakages that occur. So once Tessa was up, we actually fixed the code. It was only a syntax error, but she wasn't very happy. I later found out about me, getting rid of the code. So she spent a lot of time working on it. So we had a few chats about that, but it's all good. We're still friends. So upon reflection, what do we do well? We ran the test locally before you commit. We use collaboration tools like GitHub to move code around and do branching and all kinds of stuff. How could we improve? We could agree the rules for timing for team coding up front. That could have been a good one. So this brings me to the night before our vForum event. So we had our hackathon number 1, and this was our second hackathon. We all kind of flew in early, and we all got into a room and had a dress rehearsal. And like all things, okay, we had challenges. Things started to go wrong. So just to give you a quick overview, this is actually the code which we use, and this is the blue box is here. Is code that works on explore, evade, and optimal direction. Okay, so what we did is we broke these out into these sections because we said earlier we couldn't get the H bridge, and we were testing in different areas. We needed to be sure that we could change the code and not affect all the rest of the components. So if I swapped out the H bridge or whatever, we just have to change this one here, which is called drive me tank, and then we went from having 4 ultrasonic sensors down to just having 2, and then a pivot that turns at the front. And there we had a file called sensors.py. So we kind of broke everything out into modularization, okay? So what we plan to do in phase 2, we'd actually probably separate this out even further into containers and some microservices, just so things can run a bit more independent of the modules themselves, and we'd also get a bit more performance out of doing that, which I'll touch on a bit later on. So anyone ever seen this? It's not my fault. So let me just play the video. So here's our rover, and it's just driven up to an object, and it's frozen right there. So the sensor is just look left, look right, and it should go back to the middle, but it's frozen. So Tessa said, well, I said it must be the coding. She said it must have been the hardware. So we had a bit of a conversation, and I went home that night and I rewired the whole thing from sensor to resistors to even components. We tested it, still had the same problem. After a bit more, this was the dress rehearsal issue we had. After a bit more pulling our hair out, I changed the pin, the GPIO pin that you saw earlier in the Raspberry Pi. We recut the code because you have to tell it that you're now talking to a different pin, and everything was fine. So we changed everything but the component that was there. Okay. So this is our vForum event. Okay, so we had. Just to give you an idea, this is at Luna Park in Sydney, which is an amusement park. So this big thing that is spinning around here, kids go and sit on the edge of this, and it flicks them off as it spins around, and it's a slippery surface. So here we had problems where we hadn't tested this before in such a large area. We'd only had a 2-meter area, right? So, and we had an ultrasonic sensor. So when the rover was trying to work out if it needed to do something for an object, it took so long for the response to come back, and it was waiting because we had essentially our code was running in series instead of parallel. So we were waiting for things, and the rover was really jarring around instead of moving smoothly. So we had to change a lot of those settings on the fly. Also had a couple of problems with noise. So because it's ultrasonic sensors, when you get a lot of noise in the environment, it can really affect. It just became a lot less reliable. So let me just move on to the next one. So just to give you an idea of just some high-level architecture of the Rover and what was on board here. So on the left we had the things. So we had a temperature sensor on the Rover, which was giving us things like temperature, altitude, and air pressure. So these were connected to the Raspberry Pis, which were then onboarded onto Pulse IoT Center, which is our IoT management solution. And then these then connected back to our edge data center on Mars, which was basically where VeloCloud, our network solution, was terminated, and then that communicated via the interplanetary connection back to Earth to then send all the data to Pulse. Okay, so just tying back some of the VMware components to this. That made the whole solution. We've got Pulse IoT Center at the top left here, which is, as I said, it manages, monitors. You can use it to secure and onboard IoT devices at scale. And we had VeloCloud, which was providing the network between the Raspberry Pis and the environment. So we used the VeloCloud was key for us to move code from GitHub and into GitHub and back. We had Wavefront, which was pulling the sensor data out and put into a nice dashboard that we could actually interpret what was actually happening. And we had an influx database, which was managing and just manipulating some of that data on the way in. And obviously we had the Mars Rover, which was our autonomous vehicle that made decisions of where it was going to go based on the programming code. So here's a quick video that I'll just see if this plays, and you can see it. So here it is moving around the environment. So it will get to a wall, and remember this sensor, it's got a radius of about 30 centimeters, I think it is. So it detects that, then it reverses back, and decides this is doing this all on just based on the programming. It's not, you could stand in front of it and it would move around you. So here you might see that this place was really slippery. So some of the other things we had to encounter was, we had to get a bit extra grip on the wheels. So we originally had Velcro on the wheels, and then we took some of it off. So it's a really interesting engineering kind of project. So here's the Wavefront dashboard. So this was giving us, as I said, some of the telemetry, and it's pulling this in from the temperature device that was on the Rover. That one was when it was outside of the Rover. When it was inside the body, it reads about 28 to 29, so that was when it was outside. So clearly the aircon was kind of working then. And the camera on the front there was providing a feed as well, so it would track you, and you could see yourself on film, so that's pretty cool. This screen is Pulse IoT Center, so here you could log on and you could see this one, FEVR 11P. That's the platform. We had two Raspberry Pis. One did the telemetry, one did the platform or the drive essentially. So you could see here that there was a bit of CPU usage. That might have been we had uploaded some code or something. And then here we had VeloCloud. So we had two links. One was a Wi-Fi link, a mobile link, and one was a network link. So VeloCloud was using that. VeloCloud, our SD-WAN technology, will put those links together to look like one, and we'll make that link a lot better. And then it tells you, so as you can see down the bottom there, this is the performance increase that you get from combining those links. That's just one factor of SD-WAN. There's a lot more we could go into that, but you guys might have seen some sessions on that already around things you can do with VeloCloud. So some of the lessons that we learned in this project, just going to talk through that. So we used Pulse IoT Center for device onboarding and for configuration management. And we used SD-WAN and VeloCloud for network config and management, right? How could we have improved this? We could have put, a bit more recognition of the hardware config for IoT. So when I said that H-bridge, understand that at the start. Having some consistent configuration in development, staging, and production. And I'll talk about that in a second. And also agree on the configuration of the team, and make sure you'll use some tools to easily share this stuff as a team. So one of the lessons here, right? So version control for even the smallest of projects. So when I talk about consistent configuration, we're talking about the process by which the artifacts and the relationship between them can be uniquely identified and modified. Okay, so can you reproduce it, change it, trace it, satisfy the compliance, and share it? Now, there's in that Jez Humble book, there's a whole section on this as well, which is so we took a lot of the lessons from this Jez Humble and some of his learnings as well. Just check how we're doing for time. So coding. So as I talked about, we had our code was set up in a modularized way. So what we did well was we designed the application to allow for the changes to the individual components. Okay. What we will do is we're going to separate that out into microservices, and some of the things. So when we had the environment where when we ran it in production, it had the 5 meters that we had to change. That we could break that out into a separate web form or web page, or something we could change easily rather than having to change the code and upload it and download it on GitHub. Okay. So the containers and APIs is something that we're looking to do, and also the config code as well that I just spoke about. So I've spoken quite a bit here about some of the lessons that we've learned here. So there's four key lessons. So this is the same for any application really, although with some unique aspects for IoT and for hardware and coding of the hardware-software interface, right? So here's our test suite that we had. This is one that we put together just around how we make sure that the Rover's running and all the components are correct and up to date. So this run book, we create a run book which basically goes through, and there's a whole heap of tests here for sensors, for optimal direction, all kinds of things that you can then, when you start the Rover up, you can run through all of these tests to make sure that it's running. We built these, we kind of enhanced these afterwards. The Rover has been, it's travelled quite a bit. It's got a few stamps in its passport. It's been to New Zealand. It came to kick off in Vegas. So we've developed a lot of these and enhanced them over the time as well. So just quickly wrapping up. So as a cloud architect, you're in a unique position to provide value to your organization's IoT project, because you understand the factors like scalability, reliability, availability, so all the ITs again, and you probably know the infrastructure, and you probably understand the native cloud application as well. So I hope today I've given you some valuable points on the people and the processes that you can go through when you're running these kind of projects. So all the tools here are here from VMware to help you work with this. So you've got monitoring and alerting, with our Wavefront. You've got the device management and troubleshooting from Pulse IoT Center, and there's a bit of coverage there as well. Consistent networking and security with VeloCloud, and then edge capacity with VMC at the edge. Okay, so all the tools are there for you. So call to action on this. So make sure you get your team together, grab yourself a couple of Raspberry Pis, and have a go at programming and understanding how these dev tools integrate. Set yourself a goal, and then learn DevOps at the edge. So here's some recommended reading, which you feel free to take a photo of this, or I think you guys will get the slides at the end so you can go through this. So there's our video by our own James McAfee. So he's one of our VMware employees. He's written a really good YouTube. There's a really good YouTube video there. And we use that a lot to help us with our GitHub programming. We use GitHub, but we really didn't scratch the surface of how you can actually you can do a lot more with it. So and then there's a book by Jez Humble. We've got a couple of white papers, and then there's the 7 minutes of terror video. I need a louder microphone, clearly. Some of the tutorials and the inspirations that we had here, just to put these up there. So we had learning Python the hard way. So introduction. We all did a course, which was a Coursera course for Internet of Things, which was actually really good. And then this was the star of the show. So we got some inspiration on the robot from a video we saw, which we modified and whatnot. So some related sessions here. Now I don't know, some of these you might have already been to. I recommend if you weren't in this session earlier, this Living on the Edge, I recommend have a look at that. I think you can see the sessions online after here. It's actually really good. It will take you through the whole Pulse IoT Center, which was how we managed a lot of the Raspberry Pis and the config. We were pushing config to the Raspberry Pi to drive left or drive right via Pulse. So that's a really key point. And then there's SD-WAN and Wavefront as well. So this is the VeloCloud piece. Okay. And with that, guys, please fill out your survey. And I may have run over a little bit, so I hope I'm not in trouble. Thank you very much.